Chapter 2-4. We're skipping 2-3. We're going to come back to that. I don't like the way the chapter does this, so what I've done is I'm rearranging it so that it makes sense that we don't have to reteach the same subject twice. Okay? So what we're doing is we're going to first do complex imaginary numbers because those are review and it's something that you already know about. So today I'm going to kind of go a little bit faster through some of the things, not extremely fast, but it is all review. Okay? Oh, honey, I could. I could go on 10 with her. Okay. Imaginary number. Imaginary number exists only because you cannot take the even root of a negative number. Imaginary number exists only because you cannot take an even root of a negative number. You cannot take the second root, the fourth root, the 10th root, the millionth root of a negative number. Do we all get that? Yay, yay. Okay? So if I have I squared is equal to -1, then what is the square root of -1? Well, the square root of -1 is going to be I squared, because that's what -1 is, which then comes out to be I. Do we all see that? Now, why do my I's look like backward J's? Because in the textbook, they italicize the I's. Do we understand that? I don't want it to look like a variable. I don't want it to look like a 1. So I purposely make it look like that italicized I. Do we all understand that? Yay, yay. Okay, so with that said, moving right along, just totally square root of -2. Now you're going to see me show all my work today, and many of you are going to be annoyed. You don't have to show all your work if you understand this, but I don't want to reteach this, so this is why I'm showing all my work. As soon as I see -2, how can I rewrite that? -1 times 2, and what's -1? I squared. And what is the square root of I squared? I, so that gives me I square root of 2. Now, your brain should be able to go from square root of -2 to I square root of 2 with nothing in between. It should. But today I'm going to make the assumption that it can't. So this is why I'm going to show all my work. Do we all understand that? Okay, now another thing. Some people from other schools may have written this as 2I, square root of 2I. Now I want to know how many people's brains in here are thinking that I, does she mean to put the I there? Is it underneath the radical? Is it not underneath the radical? I'm not sure where she wants me to put that. How many of you are thinking that right now? Okay, that is why I will not put it like that. What I'm going to do is I will never write it like this. I'll put it as I square root of 2. So that way you never guess. You never know. It's right there every stinking time. There's no question about it. It is I times square root of 2, and you know it's not inside the radical. Do we all understand that? Okay, now, next. Square root of -49 plus the square root of -12. I have to help get off of it. It's so annoying. Okay, so if I have the square root of -49, what do I need to do there? I need to ask myself, what is -49? That's going to be -1 times 49 plus -1 times 12. What is -1? I squared. Is 49 a perfect square? Yes. -1 is I squared. Is 12 a perfect square? 4 times 3. So what is the square root of I squared? What's the square root of 49? So that gives me 7I plus, what's the square root of I squared? What's the square root of 4? So give you 2I square root of 3. Are those terms like terms? Why? Because one has a radical and one does not. Yes, they have the same variable being I, but I is not technically a variable in this problem. It's a number. Do we all understand that, yes or no? Okay. Moving right along. If I squared is equal to -1, what's I cubed? I cubed, you're guessing, is going to be I squared times I, and what is I squared? -1. So that's -1 times I to give you -I. Not what you thought, was it? Okay? But what you said, I said, what was I cubed? You said it's 1. It's not 1, is it? It's the square root. No, it's not, because it's negative I. Do you understand the difference? Okay. Now, what's I to the 4th? That's I squared times I squared, which is going to be negative 1 times negative 1, which is going to be 1. Do we all see that? I to the 5th is going to be I to the 4th times I. What did we just calculate I to the 4th to be? 1. So this is going to be 1 times I, which is going to be I. So your possible answers are going to be negative 1, negative I, 1, I. Yes, there's a pattern. Does anybody here want to memorize the pattern where it's going to work out later on? I don't. Do you? If you do, you're nuts. So, with that said, how do I do I to the 39? Well, what are the two values that are numbers with I squared and I to the 4th? Right? Those are my two number ones, right? I squared is going to be negative 1. I to the 4th is going to be positive 1. Correct? So my question to you is 39 divisible by 4 or 2? No, it's not. Now I'm going to break this down into what it is divisible by. So I know I can make it divisible by 2, because what's 38? Actually, I should back this up. I can make this 38 times I, right? Because 38 plus 1 is 39. Right? 38 plus 1 is 39. Right? And is 38 divisible by 2 or 4? What is it divisible by? 2. So I can make this I squared raised to the 19th times I. Why would I want to do that?
That look really ugly.
Why would I want to do that? Because 2 times 19 is 38.
Terrible.
Okay, well what is I squared? Negative 1. That's what I know. That's what I know, right? Now what's negative 1 to the 19th power? Negative 1 to the 19th power is going to be negative 1 times I, which is going to be negative I. Obviously, we need to do that again, don't we?
No. Hold on, just look. Okay, I get it.
Okay, let's do it again. I took 17. 17 divisible by?
No.
By 2 or 4? No. So I'm going to make this I to the 16 times I. Correct? 16 divisible by 2 or 4? By both. So which one do you think we want to use? I would use the 4 because it's a lot easier. So I to the 4th raised to what power is I to the 16th? 4 times I. So what's I to the 4th? 1. Anything raised to the power, 1 raised to any power, it's always going to be 1. So that's just going to be I. Sounds like a problem you got. Okay. Next, example. Square root of 10 over the square root of negative 2. This is going to be 2 times the square root of 5 over the square root of 2 times the square root of negative 1. Why did I do that? Because negative 2 is negative 1 times 2, correct? And I can go ahead and separate these, and I can make those 2's cancel out, and that's going to give me the square root of 5 over I squared, which gives me the square root of 5 over I. Yes? However, can I divide by a negative, can I divide by I? No. I can never have a radical or an imaginary number in the root. Alec first. 5? Negative 1. They're not attached. Okay. 2 times negative 1 gives me the negative 2. I separated them because negative 1 is I squared. You with me?
What happened with the square root of 2? What happened with
B square root of 2
no,
cancel.
that one.
Negative 1 turned into I squared
Why is it here?
because the square root of I squared is
So that's it.
I. Okay. So now, I simplified it, but I have to rationalize it because I can't have an imaginary number in the denominator, can I? So what I have to do is I have to multiply this by something. I need a number down there. So what imaginary numbers are numbers? You know, that sounded really weird just now. What imaginary numbers are numbers? What imaginary numbers turn out to be real numbers? I squared, which is negative 1, and I to the 4th, which is going to be positive 1. So we're going to multiply this thing by I so we can turn that into an I squared. Do we see that? Yes or no?
Wait, why?
Because I want an I squared in the bottom because that gives me a real number.
Yeah.
Okay? So this is going to give me I square root of 5 over I squared, which is going to be I square root of 5 over negative 1. And what happens to the negative?
Oh,
Can I move it to the top? Sure. Negative I square root of 5.
how is it?
Why is the I become negative?
Because the negative is in the denominator, and I can move to the numerator and make it not a fraction anymore. Okay. Negative square root of negative 24 over the I cubed. Okay, what do I notice about square root of negative 24? Well, that's going to be I squared times, what are the perfect square factors of 24? 6 and 4. 6 not so much, but 4 is, correct? We understand that. What is the square root of I squared? The square root of 4 is? And that's going to give me 2I square root of 6 over I cubed. Now, what can happen? Or I can cancel them out, right? I have 1 I on the top, and I have 3 I's in the bottom, so that's going to give me an I squared left over. Do we see that? Which is what? Which is then what? Negative 2 square root of 6. Very good.
So that negative 1 always attaches to the numbers.
Okay, we're going to skip that one. Okay, these are little problems. I want to make sure that your brain comprehends this before I give you guys homework tonight. Because this is review, and yes, I'm expecting you to remember it, but many of you are looking at me like you don't remember all of this. So I'm going to go over this with you. Now, if I have negative 5I quantity squared, what is that? That's negative 5I times negative 5I. And what's the negative times the negative? 5 times 5 is 25, times I times I is I squared, and what is I squared?
Oh my goodness.
Negative 1 to give me negative 25. Do we get that? Okay, divorce these. That's negative square root of negative 3 over square root of 16. I don't believe in divorce either, however, it is what it is, right? So now, mathematically divorce them. Now, here I have the square root of I squared times 3 over, what's the square root of 16? 4 to give me I square root of 3 over 4. Done. We already did this one. And I should do this one. Uh-huh. Uh-huh. I'm thinking. I square root of 3. I squared times 3. All divided by 4. Are we ready? Okay. Course these mathematically. So that's going to be I squared times 5 over the square root of 4 times the square root of 2. Can we see that?
4.
So that's going to give me negative I square root of 5 over 2 square roots of 2. Where did I get the square root of 4? Turns into just positive 2. Did we all see that? Did you say nope?
Yep.
Okay, you see that this I squared turns out to be I. This the square root of 4 turns out to be 2. Yes? Okay, now, am I allowed to have a radical in the denominator? No, so I have to rationalize that. So how do I rationalize that? How many 2's do I have to have down underneath the radical sign? Pull 1 on the outside. 2. If it was a 4th root, I'd have to have 4. If it was a 10th root, I'd have to have 10. We all understand that. So I'm going to multiply by what I need. I need another square root of 2. So that's going to give me I square root of 10 over 2 square root of 4. Yeah, I missed my negative there. What is the square root of 4? 2 to give me negative I square root of 10 over 4. Are you guys remembering this?
Not at all.
A little bit. Remember how much I hated it.
I mean, I remember learning this, but I don't remember what we learned.
Okay, now, what's your instinct wanting you to do? Your instinct is wanting to marry those together and make that negative 12 times negative 6, huh? Your instinct is wrong at this part. Because whenever you have a negative value underneath the square root, you have to deal with that negative imaginary number first. So what we're going to do here is you're going to pull this out, and you're going to make this 5 times I squared times 4 times 3. Why is that I squared? Because it's a negative 12. Why is that 4 times 3? Because 4 is a perfect square. Times 2 times I squared times 6. 6 does not have any perfect square factors, does it? So now, simplify each one of these. That comes out as an I, that comes out as a 2 to give me 10I square root of 3 times, this comes out as an I to give me 2I square root of 6. Have I lost anyone on what I did up there just now? Okay. Negative 12 gives me the I squared, right? The 4 times the 3, why is it the 4? Because it's a perfect square. So the square root of I squared is I, the square root of 4 is 2, 2 times 5 gives me 10, bring down the I, square root of 3. Make sense? Okay. Now, I can marry the outsides together and the insides together. So what is 10I times 2I? 20I squared. And what is 3 times 6? 18. And are there any perfect square factors of 18? Yes, there are. 9 and 2. The I squared gives me negative 20 times 9 times 2. The square root of 9 is 3 to give me negative 60 square root of 20. That's 2. Now, I want to make this very clear. If you would have married these, would you have gotten a negative 60 at the end down here? No, you would have gotten a positive 60. We got to get the correct answer. No. Do we all understand that? Okay. Now, complex numbers. You don't need to write all this down. Do not write all this down. Okay? Complex number is a plus bi. Write that down. A complex number is a plus bi. A is a real number. Bi is going to be the imaginary. Okay? The complex number is going to be a plus bi. A is the real, bi is the imaginary. Now, what's the important part here that I need you to remember? Is complex conjugates. Complex conjugates mean that the real number stays, but the conjugate would imply that the imaginary number changes its sign. So if it was positive, it becomes negative. If it was negative, it becomes positive. Okay, now how do I do this? How do I multiply two things together like this? They're technically two binomials, right? So what can I do? FOIL, right? So if I FOIL this, 9 times 6 is, or 9 times 7 is 63, minus 72i, plus 35i, minus 40i squared. Now what does the I squared turn into? -1, which means this whole thing turns into positive 40. Do we see that? Yes or no? So what's 63 plus 40? 103. What's 72 plus -72 plus 35? -37i. And you're done. Do we understand how to multiply two complex numbers together? We're good? Yep. Okay, now, dude, just speak. I don't know unless you speak. I didn't hear you. I just told it. My seeing's great, my hearing not so much.
So which one of the guys was this?
Is that 10 to the third or 1 of 3?
130.
How would you contact the one before you lost it?
Because this is actually going to be -40 times -1. Because I squared is -1. Make sense? Are you done, Pam?
Yes, ma'am.
I don't want to see you throw that back there. If I give you A, B, and C being those complex numbers, A is 2 plus 6i, B is 7 minus 9i, and C is -10 minus 7i. I want to know what my conjugate of A is. And the way I'm going to denote that is a bar over the A. How many of you remember seeing that last year? No? Okay, anytime you see a bar over a letter, that's indicating that it's pointing the conjugate of it. So what's the conjugate of 2 plus 6i? 2 minus 6i. Very good. What's the conjugate of B? 7 plus 9i. What's the conjugate of C? Nope. -10 plus 7i. Okay? Do we all see that?
Why does it stay negative?
Because the real number stays exactly the way it is, only the imaginary part of it changes its sign. So what is A plus BI? Well, A is going to be 2 plus 6i. B is going to be 7 minus 9i. Do I need parentheses around those? No, because I'm not distributing anything into them. So therefore, 2 plus 7 gives me 9. 6i minus 9i gives me -3i. Done. Agreed? Now, what is A minus C, the conjugate of C?
2 plus 6i minus 20.
Well, that's going to be 2 plus 6i minus the conjugate, which is going to be -10 plus 7i. Now, what do I have to do?
Distribute the negative.
Distribute the negative, so that's going to give me 2 plus 6i plus 10 minus 7i. So I'm going to add the real parts together. So 2 plus 10 gives me 12. And I add the imaginary parts together to give me -i. You can understand that. I don't care if you put plus, minus, or minus. Does that work? Gonna make mistakes. It's fairly possible.
It's negative, it's almost positive.
It was the conjugate of it. So the conjugate was -10 plus 7i. Did I write the wrong thing down here? That gives you positive, that gives you negative.
No, you just did.
I did plus negative. It's the same thing.
Oh, I didn't do that.
Yeah, I mean, it's the same thing. You say potato, I say potato. Plus, negative, and minus, same thing. I wrote plus, and I saw it was negative, and I put the minus in. Okay, if I have A divided by C, what is A divided by C? Well, what's A? You wrote it down. 2 plus 6i, and what's C? Negative 10 minus 7i is C. Now, I'm dividing by a complex number meaning I have a real and an imaginary part. I cannot have any imaginary numbers in the denominator, can I? Since I can't have that, what do I have to do? I have to multiply the top and the bottom by its conjugate. So the conjugate of negative 10 minus 7i is going to be negative 10 plus 7i over negative 10 plus 7i. And what you're going to do is immediately put parentheses around all of this jazz. Right? And do what? Nope, not cross multiply. FOIL. Okay? So that's going to give me negative 20 plus 14i minus 60i plus 42i squared all over. Now here's the kicker. When you multiply two conjugates together, what happens to their outer terms? They disappear, they cancel. So do I have to FOIL the entire way? No, I just have to do my first terms. Negative 10 times negative 10 is 100. Minus my last terms, 49i squared. Do we see that? When you multiply conjugates together, the outer and inner cancel out every time. So now, what is going to be 42i squared turn into? That's going to be minus 42. And what's minus 49i squared going to turn into? Plus 49. Why? Because what's the I squared turn into? A negative 1. So now combine like terms. What's negative 20 minus 42? Negative 62. What's 14i minus 60i?
46.
Minus 46i. And what is 100 plus 49? Done. Okay? Now what if I wanted you to separate this into the real and the imaginary parts? They're the same answer. Okay? How do I plot this? Oh, I'm sorry. That's going to need something.
Move all the hard objects out.
What? This one right here. This is complex number form. Real, imaginary.
I remember.
It just depends. Your back book is probably going to give you a complex number form. So if you get something like that, that's why. Okay. How do I plot 2 minus 3i? Well, this is very easy. Your real axis is your x-axis. Your imaginary axis is going to be your y-axis. So I'm going to go to the right 2 and down 3. Bam.
Wow.
There is 2 minus 3i. Real hard, right? Brain farts, anybody? If I have negative 7 minus 2i, what do I do? 1, 2, 3, 4, 5, 6, 7. There it is. Can we see that? All right, I'm going to pass out tonight's homework to you.
For every possibility of 2 minus 3.
You'll never see a complex number written like that. Complex number will always be written as real and imaginary. That's totally going to be very loud. Okay, hold over your box. Okay, now, are we listening? That is very self-explanatory. If you're looking at problem 22, 2 over 1 plus I minus 3 over 1 minus I. You need an LCD here. What is your LCD between those two? When in doubt, multiply them together. when in doubt, crap. I know, I love that one. Okay? So I need each one of these denominators to turn into this. So what did I multiply 2 by to get the 1, what did I multiply 1 plus I by to get 1 plus I times 1 minus I?
1 minus I.
So that's going to be 2 times 1 minus I. What did I multiply 1 minus I by to get this jump in the new denominator?
1 plus I.
So that's going to be 3 times 1 plus I. Now, this is going to be written as one fraction. I wrote it as one fraction because it has the same denominator.
Can you just connect them all? You get out of it. Please get that stuff.
As long as you don't lose this negative. Okay? So now I'm going to FOIL these. So that's 2 minus 2i, minus 3 minus 3i. And then these are what? What are those? They're binomials, but more importantly, what type of binomials are those? They're conjugates. So do I have to FOIL everything? No, I'm going to FOIL the first and then the last. And what is I squared? Plus 1. Oopsie. So that's going to give me negative 1 minus 5i over 2. Have a grandiose day. Catch you all later.
You like try our brains and expect us to go the rest of our day.
I do. You're right.
Okay, I got another hour right
Just a little bit of electric shock therapy.
I like your shock.
Don't mention like work.
I like go home and
Have a magnificent day.
Boy, you do.